Question number 2. Find the coordinate of the stationary point on each of the following curve and determine the natural of each of the stationary point. So we can rewrite as y equal to x to the power half plus 2x to the power negative half. Then the first derivative dy dx will be half x power negative half plus 2 times negative half x power negative half. So the dy dx equal to 0, then we have the 1 over 2 square root x minus this is 3 over 2, not 1 over 2. This is 3 over 2 minus 1 over square root x cubed equal to 0. Okay. So this one is cancelled. So we have this is half x power negative half minus x power negative 3 over 2. So the second derivative, so d2y dx squared is equal to half times negative half x power negative 3 over 2 minus negative 3 over 2 x power negative 5 over 2. So it's negative 1 over 4 square root x cubed plus 3 over 2 square root x power 5. So for this one, we multiply with the so this one I move to this side. So 1 over 2 square root x is 1 over square root x cubed. So we have the square root x cubed over square root x is equal to 2. So this one move here, this one move there, and this will be x equal to 2. Okay, so 3 over 2 minus half. Okay, so this one is actually x power 3 over 2 minus half is x power 1. So x equal to 2. So when x equal to 2, y is square root 2 plus 2 square root 2. So this one multiplies square root 2, then it will become square root 2, okay, plus 2 square root 2 over 2, then will become 2 square root 2. And the second derivative, when x equal to 2, this will be negative 1 over 4 square root 2 to the power 3 plus 3 over 2 square root 2 to the power 5. Okay, then we have the negative 1 over 4 square root x power 3, and then plus 3 over 2 square root x power 5. When we substitute with 2, then it is square root 2 over 8, then it is greater than 0, so it is a minimum point. So 2 square root 2 is a minimum point. Correct. So D, we have y equal to x squared plus 16x power negative 1. So the dy dx will be 2x minus 16x power negative 2. And the second derivative will be 2 plus 32x power negative 3, which is 2 plus 32 over x cubed. So we have the dy dx equal to 0, 2x minus 16x power negative 2 equal to 0, 2x equal to 16 over x squared, x cubed equal to 8, x equal to cube root of 8, which is 2. So when x equal to 2, y is 2 squared plus 16 over 2, 8 plus 4, then it's 12. And we have the second derivative when x equal to 2, 2 plus 32 over 2 power 3, 4. And this is 6 greater than 0, so it is a minimum point. So we have the 212 is the minimum point. Okay, so 32 divided by 8. 32 divided by 8, then we have the 4. 4 plus 2 is 6. It's correct. C, we have y equal to x power negative 1 minus 3x power negative 2. So the dy dx is negative x power negative 2 plus 6x power negative 3. And the second derivative will be 2x power negative 3 minus 18x power negative 4. So when we have the dy dx equal to 0, then we have the 2 over x cubed minus 18 over x power 4 equal to 0. 2 over x cubed equal to 18 over x power 4. So x power 4 over x power 3 equal to 18 over 2. So we have x equal to 9. Okay. Uh, this one, I make a mistake here. This is 1, not 2. Okay. So it's 18. X equal to 18. No. dy dx equal to 0. Well, dy dx equal to 0 should be this. So negative x squared plus 6x negative 3 equal to 0. So we have 6 over x cubed equal to 1 over x squared. So 6 equal to x cubed over x squared when x equal to 6. That's x equal to 6. So when x equal to 6, y equal to 1 over 6 minus 3 over 6 squared. So 1 over 6 minus 3 over 6 squared. Then it's 1 over 12. And the second derivative when x equal to 6, then is 2 over 6 cubed minus 18 over 6 power 4. So 2 over 6 cubed minus 18 over 6 power 4. Then it's negative 1 over 216 less than 0 minimum. So we have the 6 and then 1 over half is not less than 0 is maximum. So it is a maximum point. Okay. So 2D. So some students look at this question, they may think that they need to use the quotient rules. But actually we know it. We can write as y equal to 12 over x minus 1 over x cubed, which is the 12x power negative 1 minus x power negative 3. So the dy dx is negative half x power negative 2 plus 3x power negative 4. And the second derivative will be the 24x power negative 3 minus 12x power negative 5. So if we have the dy dx equal to 0, then it's negative x negative 12x power negative 2 plus 3x power negative 4 equal to 0. Then we have 3 over x power 4 is 12 over x squared. Then we have the 3 over 12 is the x power 4 over x squared. So we will have the x squared equal to 1 over 4. X will be plus minus square root of 1 over 4, which is plus minus 1 over half. So when x is half, then y will be 12 half square minus 1 over half to the power 3. So we have the 12x squared minus 1 over x power 3. Substitute with 1 over 2. Then we have 16. Okay. And then the second derivative when x equal to half, then we will have 24 half to the power negative 3 minus 12 half to the power negative 5. Okay, then we have the half 16. This one we have the 24x power negative 3 minus 12x power negative 5. Substitute with half. Then we will have negative 190 less than 0 maximum. So half 16 is the maximum point. Okay, and then when we have x equal to negative half, y will be the 12 negative half square minus 1 over negative half to the power 3. So this one, CLC, negative half, then we will have negative 16. And then the second derivative when x equal to negative half will be 24 negative half to the power 3 minus 12 negative half to the power negative 5. So CLC negative half then is 192 greater than 0 minimum. So we have the negative half negative 16 is the minimum. So we have the half 16 is the maximum, and then we have the negative half negative 16 is the minimum. Yes, correct. So for this one, we have to use the uh, quotient rule. So we have the y equal to u over v, then the dy dx will be the vu prime minus the uv prime over v squared. So the dy dx here will be the 1 plus x squared times 1 minus x times 2x, and the whole thing divided by 1 plus x squared squared. So this will be 1 plus x squared minus 2x squared. So it's 1 minus x squared, and then over 1 plus x squared squared. So over here, we to find the second derivative for this will be very difficult. So we will use other method to check whether it's maximum or minimum. But before that, we find the dy dx equal to 0, that is 1 minus x squared over 1 plus x squared squared equal to 0, then 1 minus x squared equal to 0, x squared equal to 1, x equal to plus minus 1, which is plus minus 1. Okay, so over here, we have the x, so we have to do a table here. So we have the x, then we have three values. We have to find three values here. Okay, so we have 1. So before 1 is 0.9, after 1 is 1.1. So we find the dy dx. So dy dx is the 1 minus x squared over the 1 plus x squared and the whole thing squared. So when we substitute with 1, then it is 0. Okay, but when we substitute with 0.9, then it will be this value, which is positive. And when we substitute with 1.1, so it is negative. Okay, So this is negative value. So this is actually the gradient. So the graph for this will look like, okay, mm, we will have the positive, 0, negative. So look like this. So it is a maximum. Okay, if we have a negative, negative 1, so number 9, negative 0.9, negative 1.1. Okay, so imagine we have a number line here. So we have a number line, and then we have the 0 somewhere here, then 1 is here, then this is negative 1, negative 0.9, and negative 1.1. Okay, for positive, no problem. So positive, we will have number line like this. Then we have the 0 is here, then 1 is here, then 0.9 and the 1.1. So we substitute with negative 1, then it's 0. And we substitute with negative 1.1, then is negative value. Okay, so this is 0, this is a negative value, go down. Okay, and we substitute with negative 0.9, then it is positive value. Okay, so this is positive, go up. So this is the minimum point. So when x equal to 1, so y equal to 1, so this will be the x 1 plus x squared. So when we substitute with 1, then it's 1 over 2. Okay, so 1 over 2 is the maximum point. So x equal to 1, y equal to 1 over 1 plus 1 squared is half. So when x equal to negative 1, y equal to negative 1 over 1 plus negative 1 squared. So it's negative half. So negative 1, negative half is the minimum. So substitute with negative 1, then it's negative half. Yeah. Okay. So this is how we uh, check whether it's maximum or minimum when it is difficult to find the second derivative. So question number 2 at uh, we have the y equal to uv. So the first derivative will be uv prime plus the vu prime. So the dy dx here will be the x power 1 over 3. Now what? Oh, we don't do it this way. We will just expand this one. So 4x power 1 over 3 minus x power 4 over 3. So the dy dx will be 4 1 over 3 x negative 2 over 3 minus 4 over 3 x 1 over 3. So it is 4 over 3 x power negative 2 over 3 minus 4 over 3 x power 1 over 3. Okay, so the second derivative d2y dx squared will be 4 over 3 minus times minus 2 over 3 x power 5 negative 5 over 3 minus 4 over 3 times 1 over 3 x power negative 2 over 3. Then it's negative 8 over 9 x power negative 5 over 3 minus 4 over 9 x power negative 2 over 3. Okay, then when we have the dy dx equal to 0, then we will have the 4 over 3 x power negative 2 over 3 minus 4 over 3 x power 1 over 3 equal to 0. Okay, so we will have the 4 over 3 and then 1 over cube root of x squared equal to 4 over 3 cube root of x. So this cancel with this, then we have 1 equal to x. Okay, so x equal to 1. Because over here is x power 1 over 3 multiplied with x power 2 over 3, that is x power 3 over 3, that is x power 1. So x is 1. Okay, so when x is 1, y equal to 4, 1 power 1 over 3 minus 1, 4 over 3, 4 minus 1, 3. So we have the 1, 3 here. Okay, so the second derivative x equal to 1 is negative 8 over 9, 1 minus 4 over 9, 1. So it's negative 12 over 9 less than 0, minimum. Less than 0 is maximum. So we have the 1, 3 is the maximum point. Okay, that